Hello and what is up? Welcome to Radical Academy. My name is Mike Warrior and also founder of Radical Academy. Okay, so now in this video we'll be looking at forces and fluids, of which I believe that you and I will actually understand the meaning of the force as well as the meaning of fluid. Okay, so now in this simple introduction to forces and fluid, we'll be looking at our main interesting part is to understand what is actually pressure, as well as also solve problems that involves pressure. And then also we'll look at what is application of Pascal's principle, which was actually formulated by one of the famous physicists and scientists who came up with this principle, which states that the pressure applied at a single point actually is distributed equally in the confined container, and the applied pressure is equal to the entire pressure of which is being exhausted, which is being produced in that particular container. Okay, so ladies and gentlemen, if you are new to this channel, please don't forget to subscribe, like and share, and also follow my Facebook page at Rain with Professor Warrior, and also for YouTube, go to YouTube and search for Radical Academy, and then you see and be able to receive all these kind of videos. Okay, now with that being said, now let's jump into our main content. Okay, so now we'll be looking at what in the actual sense is pressure, but we'll not kind of dive so much into what force really is, and we'll just actually tack on the surface what the force is. And then our main focus is to understand what is fluid. Okay, is a solid object or material regarded as a fluid, or is a liquid water regarded as also fluid, or a gas, is it regarded also as a fluid? Okay, so we also get to dive in that kind of aspect. Okay, and then from there now we shall come to the concept of understanding the principle upon which pressure is built upon. Okay, because we understand that we have this general perspective that there's so much pressure, like human being, they experience this kind of pressure, like things that are going over in their lives, like things are just getting so tough, you know what I'm saying? Like someone is just kind of confused, is so much into pressure. Okay, the kind of a pressure that people talks about when they face so much challenges in terms of the studies, in terms of maybe someone is failing so hard, and so forth and so on. Okay, so we will now define this pressure mathematically. Okay, and in terms of metaphysics. Okay, and then the problems, the challenges, we shall see how we can be able to apply the formula that can help us to solve challenges within in terms of pressure. Okay, so now when you look at pressure, right? Pressure is for, if you want actually to experience what pressure is, you get to exert a force that's gonna actually cause something, and that something can actually, result into something else. Okay, or some kind of action can be performed. Okay, when a force is applied on a specific area of an object. Okay, so in most of the daily lives that we experience, actually we each and every single day of our lives we experience these forces that causes us to change in terms of emotion, forces that can deform something into something else. Okay, we normally see things like the tsunamis, the earthquakes, and the volcanoes. Okay, when they erupt, they cause something. Okay, they damage things. Okay, because they come with a certain force onto something else, and then when the things react together, okay, they get to be dismantled. Right? They get to dismantle because there's some form of collision. Okay. Okay. So now, when you look at force, okay, so a force is simply, a force can be defined as the amount of an object, I mean the amount of mass, okay? Force can be defined as MA, okay? Force applied on an object can be defined as mass multiplied by the acceleration of that object. So when a force actually is exerted on an object, it causes that object to move from the initial position to the other position. Okay, so that is just simply what a force is. Now, this sometimes when you look at this acceleration, when we are talking about acceleration of an object, we are simply talking about the change in the speed of an object. Okay, so when an object is given a certain force, it has to change from the initial position to the final position depending on how much force has been given onto that object. So that object is actually going to speed up or to slow down depending on what are some of the factors that external factors that may attribute to the movement of that object. Okay. Okay. So now, the movement of an object, I want you to understand clear that the movement of an object can also be can also result from the gravitational, the gravitational movement of the earth, okay? Or rather the pulling down of an object which is pointing toward the earth's surface, okay? So we can, when we define that this can also be the weight equals to mass times gravity, okay? Normally, when objects are not moving, they are at rest, they experience what is known as a weight, which is also, in simpler terms, like a force, because they kind of have the same, units, okay? There is a mass in kg, gravity, which is a gravitational field strength of the Earth in relation to the region. Okay, so you have to take note of this formula that we are going to be using. And then from there now, we'll come to what is known as a fluid. Okay, so I want you to properly understand that when you are talking about fluid, we are actually referring to three kinds of substance. Okay, so we have liquids, we have solids, then we have gases, also have solid. Okay, now a fluid is a substance which does not actually resist, okay, resist change in terms of when a force is applied, okay. So when you look at the function, or rather the property of a fluid is that it is able to change, okay, to change in terms of movement. Okay, so the idea there is that when you look at liquids and fluids, you are simply referring to this in terms of the properties of these are the liquids. Let's say for the solid, have shape, okay, shape and size. So no shape, no proper size, and then the liquid, okay, the fixed size, but takes shape of the container. So when you look at the properties of a liquid, gases and solid, is that a solid has a property that it can have a fixed size, but the shape of the solid structure actually follows the confinement in which the liquid is actually being put. And then also, when you talk about the gases, okay, we cannot actually capture the entire gas and then confine into some form of a container. It's quite very challenging. So therefore, the gas will just take whatever things is there and then fuse it up, okay? And then we don't know the kind of the shape, the kind of a shape on the size of whatever container it can actually fill. Okay, so for the gas, it is so much of irregularities as compared to the liquids, okay? And then the solid forms both the fixed shape and then the fixed size. So these are the characteristics, or rather the properties that define what is a solid, the property of a solid, the property also of the gas, and then liquid also. So I want you to understand that a fluid is a substance, okay, that does not offer resistance to the deformation of to the deformation, okay, to deforming kind of forces, okay. So it does not offer resistance, okay. What that means is that we can apply a force on a liquid and on a gas, and something is going to actually change so much, okay. It can resist, but not as compared to the solid kind of a structure. So in that case, a solid, not fluid. Okay, so a solid is not fluid. Okay, so I hope we understand that concept. Okay, so a solid kind of a material is not a fluid because it offers so much resistance to deformation, okay, as compared to liquid and gases. They don't offer resistance to deformation. Okay, so deformation means just to destruction, okay, and what destructs either the liquid or the gas is the force that we apply onto them. Okay, so I hope you have gotten the concept there. Now, after understanding this key concept, we need to define what is pressure, and then also provide a formula that will help us to solve now problems that relates to pressure. It's a simple formula. I hope and believe that it's going to actually help you understand some of the challenges that you have been having. If you are you're doing college or university physics, this is a basic fundamentals and principles of physics in terms of fluid and forces, and particularly to pressure. So just stick around and follow me. So mathematically, okay. So now this is how best and simple you can define pressure, but of course you can also define pressure depending on what kind of a book or source of information that you're using. So pressure is just the amount of force, okay, the amount of force per unit area, okay. So this now tells us to say, I'm gonna apply a force on a particular object, okay, but my major thing that I'm interested in is actually to look at what kind of area am I applying the force on, okay. So for instance, okay, So for instance, if let's say for example, this is a book, right? Now this book is in form of a rectangle, as in mathematical figures or shapes. It is in form of a rectangle. So when you look at that thing, you have to understand what is the base structure. Okay, what is the base structure of this object that I'm applying a force on? So if I know mathematically that the base area, okay, so when I put a book like this, and then if I try to push something onto this book, so what I'm trying is it's got to go down because I'm pointing the force downward. Okay, so the more force I actually distribute via this marker, the less actually the impact. Okay, I'm going to explain that just in a minute. Okay, but the idea is you look at the base area at which the base area on the object at which you're applying the force, and then mathematically use the formula for that area. Okay, now for instance, this is a rectangle, right? This is a rectangle. So when I apply the force onto this object, then what comes out is a pressure, okay, which explains how much force and what kind of area have I actually consumed when I was applying this onto this object. Okay, so with that said, now let's take a good example on what we mean by that. But before I take you to the example, I want you to understand one thing. Okay, pressure mathematically can be written as pressure equals to force over area. So pressure equals to force over area. Okay. So pressure equals to force over area. Now again, what you need to understand is that in physics we must be concerned about the units. Okay, so the scientific units, rather the standard unit of a force is a Newton. The standard unit of area is meter squared or kilometer squared or hectare squared, depending on what kind of measurement you are taking. Okay, but the idea is that the area should be in meters, the force should be in Newton. So that should be newtons over meters and then square. Okay, so now there we can now say Newton over meter squared, which is now Newton over meter squared. Okay, so this is the standard unit of pressure. So I believe and hope that you have understood how you can define the formula. I mean, you can define the definition of pressure, as well as also know the units of pressure, and then also be able to probably, if possible, if the units were not actual meters, and then also be able to convert from one unit to the other units. Okay, so if you want to check out that video which I made on conversion of units, please, you can check up in the link up here. I'll actually you can find out more about how to convert. I will not actually go into the details of how you can convert from one unit to the other units. I believe, I hope that you understood or you have some ideas, but I hope that you can check the link on top. Okay. So now, when the pressure is in Newton per meter squared, or Newton dot m minus power 2, this can now be equated or can be said this is what is called Pascal. Okay, so that is the entire unit is referred to Pascal, okay, in the name of the scientist who actually formulated this formula. So O okay, or per. So that's how you actually get to understand the units in terms of the standard unit. Which one do you use? Okay, so those are the standard units, and I hope and believe that you have gotten how the standard unit. So make sure that when the units of meters are in centimeters or in kilometers, try as much as possible to get them back to meters, and then you can work out. Because when you do that, then that's when you can actually find the correct answer. Otherwise, if you just take the units, let's say for instance kilometers, meters, okay, so this is wrong, okay, because the standard of the meter there, the area should be in meters, not in kilometers. So when such is the case, you have to convert from kilometers to meters, and then you can now use the formula for pressure. Okay, now with that said, now let me jump into what is known as Pascal's principle or Pascal's law. Okay. Okay, so now what is Pascal's principle, and what does it even state? Okay. Okay, so to give you the glimpse and the ideas about what really is Pascal's principle, it is really nothing actually, just the simple principle which states that when I've got a balloon, let's say you buy a balloon and then you are now pushing air into the balloon, and then the balloon starts to get bigger, okay? It's getting bigger, okay? The more air molecules you put into the balloon, okay, the more space it requires, okay, for expansion, okay? So if you continue putting to an extent that those air particles or the molecules, they have now no room for them to occupy within the balloon, okay, that's gonna actually burst. And just that is the concept of Pascal's principle. Okay, now with that said, now what is indeed Pascal's principle? Okay, I'll just kind of explain the meaning of Pascal's principle, and then try as much as possible probably to illustrate in simple terms how you can understand Pascal's principle. Okay, so I'm just gonna actually demonstrate a simple experiment about what Pascal's principle is all about. Okay. Okay. Hope you have seen this board. Okay, so this is just in